Welcome. We're going to be solving some problems involving position, velocity, and acceleration. So here's our first problem. A particle moves along a horizontal line. Its position function is s of t for t greater than or equal to 0. For each problem, we want to find the times t when the particle changes direction. Okay, so it's moving along a horizontal line. We could represent that on a coordinate plane. We could see where it's located and when. We're looking for when it changes directions. So when the particle changes directions, it does have to stop. Therefore, when it stops, the velocity is going to be equal to 0. Okay, so the particle has to stop to change directions. So our first thing that we're going to do is we're going to take the derivative, and then we're going to set the derivative equal to 0 to find when the velocity is 0. Okay? So first of all, we'll find velocity, find the velocity function. Oops. Which means we're going to take the derivative of the position function. Okay. So we have s of t equals t to the fourth minus 8t cubed. And v of t is its derivative, so it'll be 4t cubed minus 24t squared. Okay? So that would be our derivative, and that represents our velocity function. So now we'll set that equal to 0 to find when the particle stops. So we'll set v of t equal to 0. So we have 0 equals 4t cubed minus 24t squared. Let's factor out a 4t squared, which gives us t minus 6. And so we have two solutions here. So we have 4t squared equals 0. Then t is 0. So our particle starts from rest. And t minus 6 equals 0, so t equals 6. Okay. So that's our critical point there when our particle isn't moving. And so now let's do a sign chart. So the next thing we need to do is we need to complete a sign chart. Because when velocity is positive, our particle is moving to the right, and when velocity is negative, our particle is moving to the left. Okay. So I'm going to just complete that over here. So I have 0, which is when it's at rest, and then 6. Right, so negative numbers aren't going to mean anything here. So let's find a number on either side of 6. So for instance, 1. Right, so if we find v of 1, okay, that would be 4 times 1 squared times 1 minus 6. Okay. Well, 1 minus 6 is going to be a negative. 4 times 1 squared, this is a positive. 1 minus 6 is a negative, so it's going to be negative. Okay. So from 0 to 6 seconds, our particle was moving to the left. Let's find out about after 6 seconds. So we'll find v of 7. So we have 4 times 7 squared, and 7 minus 6. Well, we have a positive here, and 7 minus 6 is also positive. So anything greater than 6 is going to give us positive values. So here, our particle is moving to the right. So we want to find the time when the particle changes directions, and we have our answer. It goes from moving to the left to the right at 6 seconds. So at t equals 6 seconds, the particle changes directions. So to determine when something changes directions, you're going to take the derivative. You're going to set the derivative equal to 0 and solve. And then you're going to complete a sign chart. Here we only had one solution, so we only have one opportunity to change directions. If you have more zeros to your velocity function, your particle may change directions more often. All right, so I hope this one made sense. Let's go take a look at another problem. A particle moves along a horizontal line. Its position function is s of t for t greater than or equal to 0. And we want to find when the acceleration is 0. So our steps for this problem is take the derivative twice. So we're going to take the second derivative. And then set the second derivative, which is a of t, equal to 0 to find when acceleration is 0. Right, so we have s of t equals t squared minus 4t minus 96. V of t would be the derivative, so that would be 2t minus 4. And a of t would be the derivative of velocity. And, well, the derivative of the 4 is going to be 0. Derivative of 2t is just 2. So when is acceleration equal to 0? Well, it's not. Because our acceleration is 2. Right? So we have a constant rate of acceleration, a constant acceleration here. It's never 0. So the answer to this one, well, it's not equal to 0, so the answer is never. So the acceleration is never equal to 0. Except maybe, of course, well, even at t equals 0 seconds, it has to start off, and it's going to be to change it at t equals 0 seconds too. So actually, no, the acceleration here is never equal to 0. The velocity would be equal to 0 at the beginning before it starts to move, or actually the velocity is going to be equal to 0 at 2 seconds, but our acceleration is never equal to 0. Let's take a look at another problem. That was pretty easy, wasn't it? All right, so we want to find when our particle is slowing down and speeding up. So the particle will be slowing down when the velocity and acceleration have different signs. If velocity and acceleration is both increasing or both decreasing, both positive or both negative, our particle is going to be speeding up. So the particle is speeding up when acceleration and velocity are both positive or both negative. So our first step number 1 is to take the derivative. Okay. And the derivative will be our velocity function. And so the derivative of negative t squared plus t plus 72 would be negative 2t plus 1. Okay. And our second step is to set v of t equal to 0. Because that's going to tell us about our velocity. When is our particle changing directions? When is it stopped? So we're going to set velocity equal to 0 and solve. So 0 equals negative 2t plus 1. So you subtract 1. Negative 1 equals negative 2t. And at 1/2 second, our particle is stopped. That's a critical point for velocity. All right, step number 3, we need to take the second derivative, which is a of t. All right, so a of t is negative 2. Okay, so here acceleration is always negative. Okay, so we don't have to set that equal to 0. Step 4, we need to create a sign chart to compare velocity and acceleration. All right, so we have the critical value here is 1/2. That's the critical time. Okay. And so let's take a look at what's our function doing in terms of velocity and acceleration. Okay. So we need to choose a value that is less than 1/2 and greater than 1/2. Let's choose 0. That would be a good one. All right, so at 0, people just plug in 0 there. We'll have v of 0 would be negative 2 times 0 plus 1. That's going to be positive. And so that's our acceleration. That's our velocity. So our velocity is positive, and we know our acceleration is negative because it's negative everywhere. Right, so what's happening from 0 to 1/2 of a second? Our particle is slowing down. Okay. So from 0 to 1/2 a second, the particle is slowing down. Those velocity and acceleration have different signs. Right, so let's determine something greater than 1/2, let's just choose 1. So v of 1, we have negative 2 times 1 plus 1. That's going to be negative. So our velocity is negative, and our acceleration we know is always negative. So from 1/2 to however long this particle wants to travel, the particle is speeding up. So if you want to analyze when a particle is slowing down or speeding up, you'll create a sign chart. And what you're comparing is the sign of acceleration and velocity. Okay? When they're the same, we're speeding up. When they differ, we're slowing down. Okay, let's look at another problem. All right, so here a particle moves along a horizontal line, same thing we've seen. We want to find the position, velocity, and speed and acceleration for a given value of t. So we're looking at all of those things at t equals 4 seconds. All right, so first we're going to find v of t. And our velocity function, we'll just take the derivative, would be negative 2t plus 13. Second step is to find v of 4. So we have negative 2 times 4 plus 13 is going to give us negative 8 plus 13, or 5. We should have units here. 5 meters per second is our acceleration. And actually, I think there probably was a couple that I didn't remember to put them on, and I should. Here we weren't really looking at, we're looking at time, not so much at velocity or acceleration. Same thing here. Although we could state that this was 2 meters per second squared. And over here, again, we're just looking at time. So I really haven't forgotten the units so far because we really haven't been dealing too much with units. But in this one we are, so we're going to put the units, 5 meters per second. That's our velocity at 4 seconds. That's how our particle is moving. Our speed is pretty easy to figure out. I probably shouldn't do s of t because that looks just like my position function. We'll call that the absolute value of v of 4, and I'll just put in parentheses speed. Well, since velocity is positive and speed is just the absolute value of velocity, it's also 5 meters per second. All right, and then we want to find acceleration. So that would be a of t. Oops. And we just take the second derivative, which is pretty easy. It's -2. And our acceleration at t equals 4 seconds, we have a constant acceleration here. So we're never slowing down or speeding up. We're just constant. -2 meters per second squared is our acceleration. It's our acceleration at 4 seconds and at 3 seconds and whatever seconds you want to look at. All right, so let's look at another problem. A particle moves along a horizontal line. We want to find the velocity and the acceleration. This is a pretty easy problem. We're just going to find our first and second derivatives. So take the derivative of position there would give us velocity. So v of t is 3t squared minus 2 times 28 is going to give us 56. T plus 196. And then acceleration, we just take the second derivative. 6t minus 56 is our acceleration. So that's pretty easy to find our velocity function or acceleration function. The harder part is working with them. Not that they're that difficult, but there's a little more work involved in taking a derivative of a polynomial. Let's look at the next problem. So a particle moves along a horizontal line. We want to find when the acceleration is equal to 0. And for some reason it says at t equals 7. I don't think that belongs there because we're looking for when the acceleration is 0. I don't know if my directions got moved over to another problem, but those don't make sense. So let's find the velocity and acceleration at t equals 7 seconds. And we'll find about when the acceleration is 0 in the next problem. So for each problem, we're going to find and actually, why don't we find the time? We'll just find the velocity and acceleration because we already have a t equals 7 seconds. So we're just going to find the velocity and acceleration at the given time. Again, this is an easy problem. At t equals 7 seconds. All right. So we have v of t could be written a little nicer. V of t is negative 3t squared plus 20t. And so our velocity at that time, negative 3 times 7 squared plus 20 times 7 is going to be negative 3 times 49 would be 147, right? Times 3, yeah. And then plus 20 times 7 would be 140. All right, so negative 7 meters per second is our velocity. Let's find our acceleration. So to find our acceleration, we need to take the second derivative. So that would be negative 6t plus 20. We just take the second derivative of velocity. All right, and to find the acceleration at 7 seconds, we plug in 7. So it's negative 6 times 7 will give us a negative 42 plus 20 is going to be a negative 22. And that would be meters per second squared. And if we wanted to know what's happening, what our particle is doing at t equals 7 seconds, we could just look at the signs of our velocity and acceleration. Negative, negative. So the particle is speeding up at t equals 7 seconds. Okay. Not too bad. Okay. So you should be able to analyze whether a particle is speeding up based on the sign. We want to find when the acceleration is equal to 0 in this problem. So we're going to take our derivative, find our velocity function. So our position function is negative t cubed plus 12t squared. So our velocity function would be negative 3t squared plus 12t. So really these movement equations really aren't that difficult. We'll find these ones in some trig equations. Sometimes exponential or log, but usually it's these in trig. And so now we want our acceleration. So we'll take our second derivative, and that would be negative 6t plus 12. And so to find when the acceleration is 0, set a of t equal to 0 and solve for t. So we have 0 equals negative 6t plus 12. So negative 12 equals negative 6t, and 2 equals t. So at t equals 2 seconds, the acceleration is 0. Just kind of want to note that just because the acceleration is 0 doesn't mean velocity has to be 0. Acceleration just means there would be no change in the velocity, because acceleration is the rate of change in velocity. So let's just see what the velocity would be at that time. So v of 2, negative 3 times 2 squared plus 12 times 2. I haven't done a synthetic substitution on these because they've been such nice, easy problems to plug in. So we'd have negative 12 plus 24, so it'd be 24 meters per second. So a particle is moving in the positive direction at that time, but it's moving at a constant rate of change, therefore acceleration is 0. Let's look at another problem. I don't know how many more of these I have. I guess we'll find out. When we run out of problems, we'll stop. A particle moves along a horizontal line, and we want to find when the particle is slowing down and speeding up. I don't know how you slow up. Slowing down and speeding up. Okay, so step 1, take your velocity function, take your derivative and find the velocity function. So our position function is t cubed minus 23t squared plus 120t. Velocity would be 3t squared minus 46t plus 120. A little more interesting equation than the first time we answered when the particle is slowing down and speeding up. All right, so our second step is to set this equal to 0. So we have 0 equals 3t squared minus 46t plus 120. I don't know if this is factorable. We could do b squared minus 4ac to figure that out. That would tell us whether it was factorable or not. B is 46, and I quite honestly can't do 46 squared in my head. Well, I guess I could if I wanted to, but I don't know if I want to. Minus 4 times 3 times 120. So I'm just going to grab a calculator out real quick. Oh, here's one on my podium. I'll just grab that instead of turning on the one on the computer. So 46 squared, 2,116. Minus 12 times 120. That'd be like 12 times 12 times 10. So that'd be 144 with a 0. And now we just have to figure out, is that a perfect square? 676, which is a perfect square. 676 is the square root, or is, if we take the square root of 676, that would be, not 24, 26. 576 is 24. This would be, I still want to write 24. 26. All right, so that means this is factorable. So I'm going to factor it. All right, so we have 0 equals 3 times, and there's no common factor either. So 3 times 120 would be 360. Oh, and actually, you know, if I took the time just to multiply those together, I know what how we should factor this. So multiplies to give us 360, adds to give us negative 46, negative 36, and negative 10. So initially, I wasn't sure if it was factorable, and the discriminant told me it was factorable. And if I just took a second to multiply 3 times 120 and look at that b term, I would have seen, yeah, that's very factorable. So 0 equals 3t squared minus 36t minus, plus, I'm going to put plus a negative 10t plus 120. The first two become a group. Squeeze it in there. The second two become a group, and we'll pull out the common factor. Of course, it's all tied together. I can't even see the plus there. Well, you know what it is. So 0 equals 3t, t minus 12, and negative 10, t minus 12. So we have 3t minus 10 and t minus 12, which means these critical values for us. If 3t minus 10 equals 0, t is 10 thirds, and t is 12. So these are the times when our velocity equals 0. Okay, those are critical points. The other critical point is when acceleration is 0. So we're going to take the derivative again this time and find the equation for acceleration. So if we take the derivative of 3t squared minus 46t plus 120, we would have 6t minus 46. Now we'll set that one equal to 0. Easier to solve. 0 equals 6t minus 46. So 46 equals 6t. And so 23 thirds equals t. All right, so this is when acceleration equals 0. So now we'll do our sign chart. Okay. All right, so we have 10 thirds and 23 thirds. So 10 thirds is less than 23 thirds, and then we have 12. So we need to choose some values in between those and on either side of those. So we'll take a look at, I'm going to plug in 1 here, and between 10 thirds and 23 thirds, I'll plug in 5. And we'll plug in 8. Actually, 10. I like 10. Could use 8, but I'm going to do 10. All right, so let's find out what v and t, velocity and acceleration, are at those intervals there. So at 1, and I'm going to write the equations right over here so we can see them. So, and I'll write them in factored form. So we have 3t minus 10, because all we care about is a positive or is it negative. We don't really care about what the value is at this point, because we're just looking at speeding up and slowing down. So there's 1, and then a of t is 6t minus 46. All right, so at t equals 1, if I plug in 1, 3 minus 10, that's negative. 1 minus 12, that's negative. So this would be positive. And then if I plug in 1 into acceleration, that would be negative. I'd have 6 minus 46. So the velocity is positive, but the acceleration is negative. Right? And so now let's plug in a value, because we know this would be 0, right, for one of them. In this case, it was 0 for the velocity. So let's try 5. So 3 times 5, 15 minus 10, that's going to be positive. 5 minus 12 is going to be negative. So velocity is negative. How about acceleration? So that'd be 30 minus 46. That's going to be negative as well. Excuse me. All right, let's check 10 here. So if I plug in 10, I'll have 30 minus 10, which is positive, and 10 minus 12 is negative, so velocity is going to be negative. This was a 0 over here. This one was a 0 for acceleration. So velocity is negative. How about acceleration? So 60 minus 46, that's positive. So when is our particle speeding up and when is it slowing down? So speeding up. It's speeding up when the two are the same. So in between these two, between 10 thirds and 23 thirds seconds, is when we are speeding up. Right on that interval there. And then we're slowing down when velocity and acceleration have different signs. So that means from 0 to 10 thirds. And again, after 23 thirds. So 23 thirds, we forgot to check after 12. Sorry, I forgot all about the little 12 that's over there. That one was one of the solutions. Oops, we're not quite done. I didn't notice them over here. All right, so this was the 12 here was for velocity. Velocity was 0 here. All right, so that's a 0 velocity. I'll just put a 0. Doesn't matter who. And so we need to plug in a value greater than 12. Let's just choose 15. Okay? So I'll use 15 here. I forgot to find the other interval. So you want to find one before and after each of these critical points. Right? So the critical points were the zeros, the 10 thirds, the 23 thirds, and the 12. So we need points on either side of those. All right, so if I plug in 15, I have 45 minus 10 positive, and 15 minus 12 positive. So velocity is positive. And acceleration is also positive. That would be 90, right? 1630, yeah, 90 minus 46, so that'd be 50. That's positive as well. Excuse me, 44. But it doesn't matter. It would still be positive. All right, so I have to amend here my speeding up. So I'm speeding up from 10 thirds, 23 thirds. Don't forget to check after the last critical point, because I'm also speeding up from 12 to forever. And then we were slowing down from 0 to 10 thirds. And then again from anywhere else. And actually, we kept slowing down. So from 0 to 10 thirds, actually from 0 to 12. So I'm going to try to get rid of this line here so I can point it out to you when we were slowing down. So we're slowing down. Starting at 10 thirds, we have a negative, sorry, that was a 0. So we're slowing down from 0 to 10 thirds, right? So this was the sign here was negative, and negative for acceleration, positive velocity. And then between 10 thirds and 23 thirds, we're speeding up. Okay, I almost didn't see that right there. So here we're slowing down. I'm going to put down for slowing down. Just want to make sure this is clear because it's a little busy in here. So right here, we're speeding up. So this one's the up because they're both negative. Right, so they're both negative. Here they were both different. Can you say both different? So from 0 to 10 thirds, we were slowing down. And then here, here's where it didn't matter because they're again different. That's what I was looking at. So here they're also different as well. So they stay, oh no, I'm sorry, we speeded up between 10 thirds and 23 thirds. Again, we slowed down between 23 thirds and 12. So the moral of the story is, don't cram in your work, or you can't tell the difference between your pluses and your minus signs on your interval there. So that was between 23 thirds and 12. So let's recap this problem to make sure that that's clear. And I'm going to circle these two. All right, so we took the derivative of velocity, we took the derivative of acceleration, we set both equal to 0. Velocity was 0 for t equals 10 thirds and t equals 12. These values right here. So those are critical points. We set acceleration equal to 0, 23 thirds. Okay? So those are our critical points. We have to find values on either side of them. So we chose a value to the left of 10 thirds. We chose 1, and the velocity acceleration had a different sign. That meant we were slowing down from 0 to 10 thirds. At 10 thirds, velocity and acceleration were both negative. So we're speeding up. And we're speeding up to the next interval, the next critical point. So from 10 thirds to 23 thirds. At 23 thirds, their signs are different. So we are slowing down. And then we had one more critical point. That was 12. And so at 12, we took a point on the other side of 12, 15, and the velocity and the acceleration was positive, which means that from 12 to infinity, we're speeding up. So the ones I circled in green are the times where we're speeding up, from 10 thirds to 23 thirds, and from 12 to forever. The ones, those are the ups. And where we're slowing down is between 0 and 10 thirds and 23 thirds and 12. So I hope that was clear. My work was a little busy in here. I didn't give myself much space. And I'm already at 37 minutes, so I'm going to stop this video. And if I want to solve more problems, you'll see a second video, but it's probably going to be pretty short. Have a great weekend and watch this video, and I'll see you in class. Bye.